University of Chakwal, the man of value, order to please come on podium for his welcome remarks.
We cordially welcome Colonel Jamshed Shah Sahab, Managing Director, GA7 Group, and all the faculty members and students to this August function. Colonel Sahab graduated from the Postgraduate College, Chakwal, and later on he served in the Army, and after retirement I think he has ascended to such heights which should be the dream of every student and faculty over here. He is doing a great job, first of all being the MD of a big investment group in the country. So this in itself is because we need a lot of investment in several areas, all that we बात करते रहते हैं. Natural resources भी है, अपनी construction industry है, IT है, उसके बाद ये corporate farming का हम सुन रहे हैं. तो ये investors जो हैं, they are I think angels of what you call great रहमा for the country, इतने investors. तो उस हवाले से भी फिर ये है कि he is a telecom engineer by profession, and also specializes in many technical courses from abroad, for instance cyber security and the like. And he is serving through his setup many defense organizations. The most, I think the hallmark of their effort is to service our fleet of the fighter planes. The parts which we could not get, some of the guidance system for our missile systems, for instance. ये सारी बातें जो है मैं वैसे इजमाली तौर पे कर रहा हूँ, I can't go into detail. करूँ साहब अभी जिक्र किया, मुझे बड़ी खुशी हुई कि डिफेंस सेक्टर के लिए भी इनकी बड़ी खिदमत हैं, and he has got several PhDs and highly qualified people on board to provide these services. तो मुझे बड़ी खुशी हुई आज, बड़ी खुशी हो रही है इनको वेलकम करके. ये मैंने भी जिक्र किया करण साहब से कि यूनिवर्सिटी ऑफ चकवाल एक नौज़ायदा यूनिवर्सिटी है, but it has started from a very modest base and now flourished into the Indian Division's largest general university. So since then it has, I think, grown and prospered into a center which has now the capacity of design advanced IC circuits at an advanced level. वो आपको बताएंगे डॉक्टर मौसम तारड़. We have already done 2 very significant international projects. तो ये बहुत बड़ी इंडस्ट्री है. अगर I am being humbled, but I can always say that we are entering through University of Chakwal into a multi-billion-dollar industry. और इसका जो इस वक्त मरकज़ है वो ताइवान है। लेकिन होता ये है कि पहले डिज़ाइन होता है और डिज़ाइन के ऊपर आजकल ज़्यादा जोर है। फैब्स तो मौजूद हैं, चाइना में भी हैं, ताइवान में भी हैं, इटली में भी हैं, ठीक है। फैब्स आर देयर। एक माइक्रो इलेक्ट्रॉनिक की इंडस्ट्री है, द रोड विच लीड्स टू द इत्तेफाक फाउंड्री, मुझे उस रोड का नाम नहीं याद, और ये सबसे पहले 80s के अंदर ये इंडस्ट्री कायम की थी। मेरे कज़न है सोहेल Amr, who came from Florida, and then he invited the Japanese to establish the microelectronics. तो उनकी जो पहली डिवाइस थी, that was the CB radios for the army. So they are doing the fabrication in microelectronics.
I request Chairman, Electronics Department, Dr. Mohsen Tarar, to come on podium for his presentation on integrated circuit design.
For such nice words, I'm humbled. और I must admit कि before I came to know Garal Saab, I was a bit perplexed how to convey it in more appropriate manner. But now I know, mashallah, his background is also technical, so hopefully, inshallah, it will be much more easier. About my academic background and also my work experience. Secondly, then I will talk about the chip design industry application. Why do we need this application? Because every industry is driven by applications. And then why it matters, what sort of amount in terms of revenue we're looking at. These are astonishing numbers, and we will look into it. And then, of course, I will give a short introduction about my research overview, like different capacities that I did. Firstly, as a PhD student, where I designed wide power amplifier, integrated amplifier in 130 nanometer CMOS technology. The second was as a team lead at ISP Frankfurt Oder, Germany, where I did the electro-optical design. So there are two types of integrated designs. One is electronics design, or I said integrated IC design, integrated electronic design, which are integrated on the chip. And the second one is electronics plus photonics, where you have two different domains integrated on the same chip. So this has actually made us life let's say, easier, or we're getting a lot of better rate. For example, one application is the DSL lines that have been routed to our homes. That there we have insane amount of data, and hopefully it's going to increase further and further. Then we have the third design that I did as for 200 gigawatt non-synchronous amplifiers and diode design. This is basically related to this high data rate that we put on the DSL, or the where we have the communication through fiber. So this is the design that we did. I did as a postdoc when I was working there at Columbia University for 3 years. And then obviously the milestone that we have over here, which was establishment of our design. I would like to also give a brief introduction about this center and also the design lab that we have over here. So we have a fully functional lab with complete software, fully licensed software, not pirated one. And we can do the design over there. That is a great achievement under the leadership of our device master. Also, I will talk about current collaborations. Couple of current collaborations we have with ISP Frankfurt, Germany. The second one is with the International Quantum Science Academy, Shenzhen, China, which was totally made at University of Chakwal, which was, I think, a great step towards the University of Chakwal getting to the bigger picture of real level. And then finally, I will conclude my talk. So I did my bachelor's in electronics engineering, and then I did my master's in communication electronics, where I studied system on chip design from Linköping University, Sweden. There I was offered, I was lucky enough to get the Erasmus Exchange scholarship from Sweden to Germany, and there I had the master thesis topic as a power amplifier, which was a totally complete hardware implementation. And thankfully it was successful, which led to a PhD position. I was offered by the professor over there at Chair of High Frequency Electronics at RWTH Aachen, Germany, which lasted for almost 6 years. In Germany, the PhDs normally last from 5 to 6 years. In case if you wonder that why it requires so much time to spend. And then I resigned, and then I joined IHP, which is basically a fabrication facility that also provides the solution, the analog mixed signal solution, the RF solution, the wireless solution, the internet design, all of stuff integrated. It's a fab, and we have an MOU with them. And if in case of any future designs, they will also, let's say, collaborate with us, and they will also compensate in terms of area. So, for example, as you might have known, the area is very expensive part for this one. And if they are giving you free area, it means that they are also doing a huge favor, and also alhamdulillah, they are also getting designs from us. So it's a mutual collaboration. Then I joined EBS University at the University of Ulm, where I did 3 years postdoc from 2019 to 22, and then I joined University of Chakwal last year as assistant professor, and now currently I'm heading the institute. So first of all, all the industries, they are driven by the application. So application for the chip design, you can just name it, you can find it everywhere. It starts with the consumer electronics, the automotive, IT, gaming, manufacturing, power plant, utilities, your radars, sensors. So just in order to show a couple of beautiful pictures, that's the best possible way to convey the applications. On the left side, you will see it's an integrated circuit that have been populated on a PCB design on a PCB which basically belongs to iPhone 7. So these are all the components. If you just name it, you might not be able to read it, but these are power management unit, integrated the transmitters, the RX receivers, TS, all of them they are integrated on the printed circuit board, which is basically part of the PCB of iPhone 7. Of course, with new versions, we are getting miniaturization, we're getting smaller in terms of design, and we're getting more efficient. On the right side is the picture where we have a fully automated, let's say, transport system, where all the cars they are equipped with the sensors that are required for fully automated driving. So as you know that we are moving towards the automated driving, and just to show you the application, okay, the radars, that we need, the internal processing that has to be deployed inside the car. It has to have, of course, the electronics provides the base for both of them. And then just to get the numbers. So for example, if we address both these applications, then these applications are called application-specific integrated circuits. So for example, if you come to me or if you say, okay, that I would like to say a certain application, could you please make this design for us, for our fab or our group or our company, yeah? So then the design that I'm going to do for you will be called an application-specific integrated circuit. So the market starts from $300 million, and in 2030 it is going to reach $430 billion worldwide. So this is just an application-specific. So as overall generic, generally if you look at the semiconductor, which will involve silicon, which will involve silicon germanium, and also 3-5 technologies, gallium arsenide, gallium nitride, yeah. So these are the high performance technologies. So if you talk about the complete, let's say as a picture, then we started at roughly close to $300 billion as a worldwide revenue for this industry in 2012. And you can say from 2016, it stayed in the mark of let's say between $350 billion. But then there are two gigantic histograms. You can see it in 2017 and 2018. This is the time that we hit 5G. So as you know that there will be a 6G sooner, so the demand will increase ever and ever, and this revenue is going to increase again and again. So we will of course not, as a Pakistani institute, would not like to leave behind. But just to show you in the let's say in the semiconductor worldwide, what sort of contributions we are dealing with. So we have Taiwan, which is basically sitting at 75% of this world revenue that they are generating, 75%. But what are the two things that they did so that it made them successful? First of all, they started early because it's a long-step process. You do the design, you do the fabrication, you do the measurements, then you know your models. And the second thing that they did is that they poured a huge amount of money, and they made their models authentic. So basically, what you are selling to your customer, it should work the way that the data sheet is telling you. So if it is not abiding the data sheet, it means that your design is not correct, and it means that many people will look into the other industries because they are looking for exact solution in order to sell their products. Because it's all driven by the products. So in the current scenario, these are the numbers up to 2014. And recently, actually, China also came into the stage. So, for example, they also poured $200 billion into this industry throughout the years. And now, in this year, actually, according to China's Ministry of Industry and Information Technology, they have managed to get a revenue of $273 billion only from this industry. This is not including the software-based solutions. These are only hardware solutions. If we also talk about the software-based solution, then they pass $500 billion mark. So just to give you the idea how much these industries, they matter and how much they can play a role in development of certain nations or certain countries. Now I just would like to give a short introduction about the work that I've done. The first work was related to environment power amplifiers that I did as a PhD student. The design was supposed to deliver high output power with a compact design and should be efficient as well. So the design was taped in UMC 130 nanometer CMOS load, and on the left side, on the top is the circuit diagram. I would like to give a bit more detail if I was giving a lecture, but I can give you that it's a two-stage design just in order to get the required performance parameters. And on the left side, you can see the simulation and the result. So the simulation is shown in the dotted form.
Assalamu alaikum. I hope you all are fine. Good. Sir, Dr. Bilal, Dr. Mohsin and your team, I am really highly thankful and impressed also. Because once I was called by the Vice Chancellor to join, and this is my first visit to this place, and sir, really it was a surprise for me. And great contributions from your side and your all team. I know, the reaching to this point in our country is not a small benchmark or a milestone. So real appreciation for all of you. I'll come to the technology related things because I was a student of engineering like very old time in 90s. So after that I was associated with very advanced technologies. Due to my official commitment, I was learning the things, and through that I came to this conclusion: any society, any nation who wants to continue with the respect and in a powerful position, which is called a proper negotiable positions, that is only through technology. I tell you, there is no other way. And just little thing. I did my FSC from here, Government College, Chakwal. Then I had less number, I could not join engineering. So I did not waste my time by improving the numbers. I did my BA. And in 1984, we were only 2 students who passed from this college. Rest, everybody had some, at that time we used to call it compart. Now I think young people say it in a different way. Anyway, finally I was selected by the army to do this engineering, and that to telecom, because Dr. Saab has done electronics. So the first time, I thought over how this signal is generated, this electric signal, because the whole game is around it. I just read a book. After I attended 2-3 months of my initial days, I was not understanding how this energy is produced. So I went to a basic book and I studied that this is a natural phenomena which is actually invented, not manufactured by human being. Whenever on a conducting material, if some EMF, it strikes. So there is an agitation of the basic particles of that substance, and that agitation creates a electronic signal or current. From there onward, I tell you, with this little of this understanding, I got a big interest into it. And then everywhere, I studied being a telecom engineer, right from the landline to the satellite, and in between all spectrums. So I had no issue ever to understand those. So the point is not to impress you from my story. The thing is, know the basic first. I tell you, all your subjects, everything will become very understanding.
For sharing your wonderful experience with us. It's time to award souvenir to our honored guest. Therefore, I request for the Vice Chancellor very humbly to please come at the reserved place to award souvenir to Colonel Oceannewshd Shah, Managing Director of J7 Group.
It's a small
Sir,
souvenir.
thank you so
हमारी
much,
यूनिवर्सिटी
sir.
की याद आपको दिलाएगी.